All right, so what we'll do here is go and get started with problem number one, where it says here use the product and quotient rules to find the derivative of each of the following. All right, so in part A and B is the use of the product rule, part C and D is the quotient rule, as you can see. So in part A of problem number one, here we have y is equal to 8x squared minus 6 multiplied by 3x squared minus 7x plus 2. And I want to find the derivative of that function using the product rule. And the way we can do that is this. This expression will be the first term. So the first will be 8x squared minus 6. And the second will be the second term, or the second expression, 3x squared minus 7x plus 2. And here we'll just take the derivative of each one of these. So the first is your 8x squared minus 6. What would f prime be?
16x.
Just 16x. Yeah. And then for the second being 3x squared minus 7x plus 2, what would that derivative be? 6x minus 7. Okay. So now to find dy dx. dy dx is just going to be this, the first times the derivative of the second plus the second times the derivative of the first. And in this case here, the first was the 8x squared minus 6 times the derivative of the second, which was 6x minus 7. And then plus the second, that's the 3x squared minus 7x plus 2 times the derivative of the first, that's 16x. And from here, we just go ahead and simplify all of this. Now for the 8x squared minus 6 times 6x minus 7, pretty much if I use the full method, that means I do the first times the first, that's the 8x squared times 6x, that would be 48x cubed. The outer 8x squared times this minus 7, no, that's going to be a minus 56x squared. Inside would be minus 6 times 6x, that's going to be minus 36x. And then minus 6 times a minus 7 will be plus 42. Okay. And then for this part right here, we just use the distributed property, distribute the 16x over the 3x squared minus 7x plus 2. So if I do 16x times the 3x squared, that would be, wait a minute, 16 times, yeah, 48x cubed. And then 16x times that minus 7x. Yep, 112. So it'd be minus 112x squared. And then 16x times 2 would be 32x. Okay. And then from here, we just go ahead and combine some like terms if at all possible. Well, I see 48x cubed and a 48x cubed. If I add those two, I would get 96x cubed. Let's see, what else do I see? Minus 56x squared and a minus 112x squared. If I combine those two, that's going to be a minus 168. x squared. Let's see, minus 36x and a plus 32x. That's what, minus 4x, and then nothing to combine with that 42, so I'll just bring that down. So the derivative there would be 96x cubed minus 168x squared minus 4x plus 42. Okay. Are there any questions about part A? All right, part B is this. Let's say we get y is equal to 4 minus z squared. And that's multiplied by z cubed minus z plus 5. And here I want to find its derivative of that function. Well, again, this 4 minus z squared will be the first. That would mean the second will have to be that z cubed minus z plus 5. So for the first term being 4 minus z squared, what would be its derivative? Negative 2z. And then if the second is that z cubed minus z plus 5, what would that derivative be?
Z squared minus 1.
3,
3z squared, sorry.
yeah,
Z squared.
minus 1. As you bring the power down, copy the variable over to the one less power.
Where did negative 1 come from?
Derivative of minus z.
Okay.
Any other questions? Okay, so now we can find what dy dx is going to be. Again, that's going to be first times the derivative of the second. So it's 4 minus z squared, that's the first, times the derivative of the second, that's 3z squared minus 1. And then plus the second, that's the z cubed minus z plus 5, times the derivative of the first, that's negative 2z. And then we go ahead and simplify all of this. This part we have to use the FOIL method, so we have to do 4 times the 3z squared. That's 12z squared. And then I'm going to do 4 times this minus 1. That's minus 4. The inner is minus z squared times 3z squared. So it'd be minus 3z to what power? Z squared times z squared. Z to what power? To the fourth. And then finally, minus z squared times minus 1. That'd be plus z squared. Okay. And then I'm going to do minus 2z times everything inside the parentheses here. Distribute that minus 2z. So minus 2z times z cubed. I know that's going to be a minus 2z to the fourth. Then minus 2z times the minus z, that's going to be a plus 2z to the third. Then minus 2z times the 5. That'd be minus 10z. And from here we combine like terms here. Let's see what we got. I'm going to do all of this in descending powers here. Starting with this minus 3z to the fourth minus 2z to the fourth. Well, minus 3 minus 2 would be a minus 5, and then z to the fourth. Let's see, with the cube, missing something here.
Yeah, that's why I'm getting hung up there right now.
Okay, well, I think I did this wrong in my notes here, because, let me check. Let's see. That's minus 12z squared. And then that's a minus 4. Minus 3z to the fourth. Plus z squared. This one. Minus 2z to the fourth. Plus 2z cubed. Minus 10z.
This should be 2z to the second,
Which one?
the second one, right there.
Right here?
The second part. Like when you get negative 2z times z, times negative z.
Okay, you're right. So this should be minus 2z squared. Okay. Glad you caught that. All right, so now let's see what we got here. 12z squared, a z squared, and another 2z squared. That's how much? 15z squared. Okay, and all I got is minus 10z, so I can just bring that down. And all I got is minus 4, so I can bring that down. Okay. So the derivative here would be minus 5z to the fourth plus 15z squared minus 10z minus 4. Okay. Any questions on part B? Parts A and B is just using the product rule. Now part C is the use of the quotient rule. As you can see, you have a numerator and a denominator. So in part C, we got f of x equaling to, let's see where we got 2x minus 4 divided by x minus 4. Okay. Well, not first and second. Now usually with the quotient rule, we say the low and the high. So that means that the high would be your numerator. That's the 2x minus 4. And the low is your denominator, x minus 4. Well, if the high is 2x minus 4, then that means that the derivative of the high will have to be what? 2. And for the low being x minus 4, the derivative of the low is 1. All right, so now f prime of x, using the quotient rule, is always going to be low times the derivative of the high minus the high times the derivative of the low divided by the square of the low. So here we go, low times the derivative of the high. That would be x minus 4 multiplied by 2 minus the high, which is your 2x minus 4, times the derivative of the low, that's 1. The whole thing is divided by the square of the low, which is x minus 4, quantity squared. And I'll go ahead and put the 2 in parentheses. And from here we just find that derivative. Well, if I distribute the 2 over the x minus 4, what would I get? 2x minus 8. And then, well, I know 1 times 2x minus 4 would be 2x minus 4, but if I distribute this negative over this 2x and the minus 4, what would I get?
Minus 2x minus 4.
Not minus 4. Plus 4. Okay. All that's divided by x minus 4 quantity squared. And then, combining like terms here, the 2x minus 2x ends up giving me 0. So the 2x's are gone. And negative 8 plus 4 ends up being what? Negative 4. And all that's divided by x minus 4 quantity squared. Okay. All right. Any questions about part C? Okay, part D is another problem using the quotient rule. And here we got f of x is equal to, let's see, we got 3x squared minus 9x plus 8. And all that's divided by 7x plus 1. So in this case here, the high would be your numerator. That's the 3x squared minus 9x plus 8. And the low, that's your denominator, 7x plus 1. Well, if the high is 3x squared minus 9x plus 8, what would be the derivative of your low?
Seven.
I mean, the derivative, I'm sorry,
Really high.
the derivative of the high.
6x minus 9.
Yep, 6x minus 9. And the derivative of the low would be 7. So this part, the derivative of the high, that's 6x minus 9. The derivative of the low is 7. So now we can find f prime of x. So it would be the low, which is your 7x plus 1, times the derivative of the high, that's 6x minus 9, minus the high, which is the 3x squared minus 9x plus 8, times the derivative of the low, that's 7. And you know what I'm going to do here? Put the 7 in front of that 3x squared minus 9x plus 8. All that's divided by the square of the low. 7x plus 1 quantity squared. Because I'm not only going to have to distribute the 7, I also have to distribute that negative sign that's in front, or the minus sign in front. But for the 7x plus 1 times 6x minus 9, I have to use the FOIL method, which means 7x times 6x, that's going to be 42x squared. The outer 7x times that minus 9 would be negative 63x. The inner 1 times 6x, just 6x. And then the 1 times the minus 9, negative 9. And then I'm going to distribute that minus 7 over the 3x squared, the 9x, and the plus 8. Well, let's see here. Minus 7 times 3x squared will be a,
21x squared.
okay, yeah, minus 21x squared. Minus 7 times minus 9x will be
Positive 63.
63x, okay. And then minus 7 times the plus 8, minus 56. All that's going to be divided by the square of that low, 7x plus 1 quantity squared. And then we just, let's see, we can combine some like terms. Let's see, 42x squared minus 21x squared.
21x squared.
That's 21x squared. And I'm also going to do this. I see minus 63x and a plus 63x. That's gone. I'm left with 6x. And then minus 9 and a minus 56.
Minus 65.
Minus 65. And all that's divided by 7x plus 1 quantity squared. So the f prime of x ends up being 21x squared plus 6x minus 65, all divided by the quantity 7x plus 1 squared. Okay. Questions about A, B, C, or D of problem number 1. Okay, number 2. There's some trig functions that we talked about. And we're going to find the derivative of each of those trigonometric functions. So problem 2, part A. Here we got y is equal to 9 times the sine of x plus 4 cosine of x. And I want to find its derivative. And in this case, I'm going to use y prime for the derivative. Of course, the constant is the 9. We bring that down. What's the derivative of sine of x? Cosine x. Plus, bring down the 4. The derivative of the cosine of x is negative sine x. So here, y prime ends up being 9 cosine of x. And this will be minus 4 sine of x. Okay. All right. Are there any questions about part A? All right, part B is this. Say we got y is equal to sine of x plus 8e to the 0.5x. And here I want to find its derivative. Okay. And the derivative of the sine of x is cosine of x. And then plus, now for 8e to the 0.5x, I'll bring down the 8. Now what's the derivative of e to the 0.5x?
0.5 e 0.5x to the
0.5, you're right about that. And then we have the derivative of that, that'd just be e to the 0.5x. Okay? Because if you think of this, the derivative of e to the 0.5x is e to the 0.5x, and then you have to take the derivative that's in that exponential part for e. 0.5x's derivative will be 0.5. Now we can simplify this. Think of this as half of 8, which is what? 4. So I have y prime being cosine of x plus 4 e to the 0.5x. And that's all there is to it. All right, questions on part B? Okay, now part C, we got y is equal to 3 times the secant of x plus 3 cotangent of x. And here I want to find its derivative. Okay, so y prime would be this, bring down the 3. What would be the derivative of the secant of x?
Secant x, tan x.
Yeah, secant x, tangent x. And then plus that 3 cotangent of x. Well, if I bring down the 3, what will be the derivative of the cotangent of x?
negative cosecant squared x.
Right. Then pretty much I'll just simplify that as y prime equaling to 3 times the secant x tangent of x. Then minus 3 cosecant square of x. Okay. Are there any questions about problem number 2? Okay. All right, now number 3 is where we were dealing with the derivatives as rates of change. In this case, we're supposing that the position of an object is moving horizontally after t seconds is given by the function s is equal to f of t, which equals 2t squared minus 3t, where s is measured in feet with s greater than 0, corresponding to positions right of the origin. And let's say we're using the interval t greater than or equal to 0 and less than or equal to 4. And here we're going to answer the following questions. So in part A, we're going to find first the velocity function. All right, so number 3, I'm going to write the position function, which is also f of t. It's 2t squared minus 3t. And we're told that t is between 0 and 4, and that does include 0 and 4. So in part A, they want the velocity function. And anytime you're dealing with the velocity function, you're finding, in reality, the first derivative. And v of t is the same as saying f prime of t. So what would be the derivative of 2t squared minus 3t? 4t minus 3. That would be my velocity function for this position function. And then they ask the question, when is the object stationary? And moving to the right and moving to the left. All right, for it to be stationary, that means that your first derivative has to be equal to 0. And f prime of t was 14 minus 3. So we need to set that equal to 0 and solve for t. Okay, so if I add 3 to both sides, that means 4t is equal to 3. Divide both sides by 4. And I'm going to leave this as a fraction of 3/4. So that means in 3/4 of a second, that's when the object is stationary. And then they ask the interval where it's moving to the right and also moving to the left. And what I would do here is put this velocity function in our calculator, and that would give us an idea of where it's moving. Okay, so if I go to y equal to, and I'm going to clear this equation out, enter this velocity function, I'm going to treat the t like an x. So it'll be 4, and then xt theta n for your x minus 3. And let's see here, that window, and I'm going to do this from I'll do this from 0 to, let's say 10 in increments of 1. And see what happens here. And I'm going to try 0 to 10 with a y scale of 1. And then hit graph. Might need to bring that down a bit. Let me see here. Window. I'll say negative 10 to 10. Not the. Let me go back. 0 to 10 can stay for the x. It's the y that I need to change. Okay, there we go. And as you can see here, that point of intersection will have to be 3/4 because it's stationary at 3/4 when t is 3/4. I get a 0 here for 4t minus 3. But anything to the left of this, that's below the x-axis. That will have to be moving to the left. Anything above will have to be moving to the right. So if it's bigger than 3/4, it has to be moving to the right. And I have to pay close attention to this interval that I'm dealing with. I'm restricted from 0 to 4. So from 3/4 up to 4, the object is moving to the right. And then anything moving to the left will have to be something between 0 and 3/4. So from 0 up to 3/4. Notice I'm using parentheses around the 3/4 because at 3/4, that's when the object is stationary. So I can't include that.
Okay, so when it's moving, you put brackets.
Yeah. Because at these endpoints 0 and 4, you can put brackets. But where it's stationary at 3/4, I have to use parentheses. Okay. Any other questions on part A? All right, now part B states, determine the velocity and acceleration of the object when t is equal to 1. Okay, it's a different color. Okay, so let's say when t is equal to 1, of course our velocity function is at 4t minus 3, so I can just say v of t is equal to 4t minus 3. And then at 1, that's going to be 4 times t, which is 1, minus 3. And what's 4 times 1 minus 3? 1. Now my velocity, since our units are in feet per second, the velocity will have to be in feet per second. So at t is equal to 1, the velocity there will be 1 foot per second. Okay? And then they want the acceleration of the object. That's going to be a of t, which is the same as taking the derivative of your velocity function here, v of t. Well, here's our velocity function, 4t minus 3. What would be the derivative of that? 4. So our acceleration would be 4.
Where did you get 4 again?
Took the derivative of 4t minus 3. Because your acceleration function will be your derivative of your velocity function. Okay, any other questions? Okay, so at 1, the acceleration at t is equal to 1 will also be 4. So the velocity of the object at time equal to 1 would just be 1 foot per second. The acceleration would be 4, and this will be in feet per square second, as the acceleration is units per square unit of time. Okay. Any questions on part B? Okay, now part C asks this. Determine the acceleration of the object when its velocity is 0. So we want the acceleration when your velocity, v of t, is equal to 0. Well, we figured out what v of t was when it was equal to 0 back in part A. Okay, that was way up here in part A. It's going to be 3/4. All right, so when v of t equal to 0, that means the time would be, is 3/4. Where'd I get 4/3 from in my notes? But it's 3/4. All right, so they want the acceleration a of 3/4 at time equals 3/4. Well, going back up here, a of t was 4, so what must a of 3/4 be equal to?
One. What do we do, thing, 3? Wait, don't you,
A of t, that's 4.
no, I'm doing something a little bit.
Okay.
I'm sorry.
A of t is 4. So what must a of 3/4 be? Also has to be 4. Okay? Because I have no variable to substitute that in. So no matter what the t is, in this case, a of t will have to be 4 in this case. Okay. Any questions about part C? Or are there any questions about problem number 3 and how that's done?
Do we have to label the unit?
Yes, feet per square seconds. Can't forget that. Okay. Questions on problem number 3? Okay, number 4 is consider the cost function c of x is equal to 1,500 plus 0.4x. X is between 0 and 5,000, and a is 2,400. Here we want to find the average cost and marginal cost functions. So let's start with part A. So here we got c of x is equal to 1,500 plus 0.4x. X is in between 0 and 5,000, including those endpoints, and a is 2,400. So that means here the average cost function is what we're trying to find. And c bar of x is defined as this, the cost function divided by x. So here we got 1,500 plus 0.4x, which is what c of x is. That's divided by x. And I'm going to take each term in the numerator divided by the x. And when I simplify this, that 1,500 over x would just be 1,500 over x. 0.4x divided by x would just be 0.4. This would be your cost function. 1,500 divided by x plus 0.4. Now for the marginal cost function. Marginal cost function, we take its derivative, c prime of x. So the derivative of this 1,500 plus 0.4x will be what?
0.4.
Just 0.4. Because the derivative of 1,500, that's 0. 0.4x is derivative just 0.4. So that would be your marginal cost function. And that's what they asked for in parts A and B. I mean, just A. Now, part B is to determine the average and marginal cost function, marginal cost when x is equal to A. So that means if X is equal to A, and A is 2,400, we just substitute the A with that 2,500. So that means X will be equal to 2,500. Now we can find the average cost. And we got C bar of X being 1,500 divided by X plus 0.4. So we substitute the X for 2,500.
Where do we get the 2,500 from? Because it's supposed to be
Uh,
24.
24. Okay, so it'd be 1,500 divided by 2,400 plus 0.4. Let me get out of this. So 1,500 divided by 2,400 plus 0.4. Then hit enter. Now, to two decimal places, what would this amount be?
1.03.
1.03. So in dollars and cents, this will be $1.03. That would be your average cost. Okay. All right, so now for the marginal cost. Of course, the marginal cost function with C prime of X, that's equal to 0.4. So C prime of 2,400 will have to be how much?
960.
Mm-mm.
I'm trying to multiply.
A dollar?
No. Well, you only got 0.4, so if you replace, you're not going to be able to replace, there's no X in there for you to replace, so it'd just be 0.4.
Yeah, I don't know what I was doing. I was trying to multiply 0.4 by 2,400.
No, there's no X there behind it. Okay. And you have to think of this, if you were to graph this, it would have to be like a straight horizontal line. Regardless of what X is, C prime of X will just be 0.4, because there's no variable there for you to substitute. Okay? So that would be the marginal cost for 2,400 would be 0.4. So that's part B. Now in part C is to interpret the values obtained in part B. So pretty much you have to write this out. The $1.03 is the average cost. Okay? So that means when 2,400, let's say items, because we don't know what those items are produced, the average cost is $1.03 per item. Okay? That's how we interpret the average cost. And then to interpret that marginal cost, which is 40 cents, we can just say something like this: the cost of producing, let's say, one additional item. After 2,400 items are produced, is 40 cents. So part C is just writing it out in words how you would interpret the answers in part B. Are there any questions about problem number 4? All right, in problem number 5, here we're going to use the chain rule to find the derivative of each function. So in this case here in part A, let's start with part A. Here we got y is equal to the quantity x squared plus 9x plus 6. And that's to the 9th power. And we want to use the chain rule to find the derivative of each of those, of that function. Now, of course, I did show you 2 ways of finding the derivative here. But we can go ahead and just do it like this. I'll do dy dx as a notation. Best way to do this, take that exponent, bring it in front, which is your 9. Copy the x squared plus 9x plus 6 over to the 1 less power, 9 minus 1, that's going to be 8. And then we have to take the derivative on the inside. So the derivative of your x squared plus 9x minus 6 will be what?
2x plus 9.
2x plus 9. All right. And I'll just kind of rearrange these terms here. So I'll put the 9 in front and then 2x plus 9 right after it. That'll be multiplied by the quantity x squared plus 9x plus 6 raised to the 8th. And I'll go no further than that. Okay. Are there any questions about part A? All right, part B. Let's say we got y is equal to the sine of 7x to the 4th plus 6x plus 4. And here I want to find its derivative. So dy dx, what's the derivative of the sine? Cosine. So that'd be the cosine of what's in the parentheses, the 7x to the 4th, plus 6x plus 4. Then it's going to be multiplied by the derivative of the inside function. So the derivative of 7x to the 4th plus 6x plus 4 will be what?
28x cubed plus 6.
Right. And here's what I'll do. And this right here is an angle, so that stays with the cosine. But that 28x cubed plus 6 would go in front of the cosine of 7x to the 4th plus 6x plus 4. And don't try to multiply these 2 out.
Do we have to put the derivative in front of the cosine? Or does it?
Doesn't matter. But don't try to multiply these out because this right here is the angle for the cosine. Okay, any other questions? All right, problem number 6 is using implicit differentiation. Implicit differentiation. So let's say we had 7x to the 5th plus 5y to the 5th equals 12xy. And I'm going to use implicit differentiation to find the derivative of that equation. Okay, so with implicit differentiation, we take the derivative of every single term with respect to x. Keeping in mind, if you take the derivative of y, you have to include dy dx in it. So, the derivative of 7x to the fifth will have to be, right. Bring the 5 down, multiply by 7 is 35. Copy the x over to the 1 less power. Plus the derivative of 5y to the fifth. 25y to the fourth dy dx. Because we're taking the derivative of y, we're assuming that y is a differentiable function of x, so we must include dy dx. And then that's equal to, I'm going to pull the 12 out and concentrate on taking the derivative of xy. What rule can be used there? Product rule, because it's x times y. So I have to apply the product rule on this one. And that's going to be this. The first, which is your x, the derivative of y is dy dx. Plus the second, which is your y, times the derivative of x, which is 1. Okay. So now I got 35x to the fourth plus 25y to the fourth dy dx. And I would go ahead and distribute the 12 over everything in the parentheses. So 12 times x dy dx will be 12x dy dx plus, well, y times 1, that's y times that 12 in front would be 12y. All right, now the next step would be to collect all the terms that contain dy dx on the left side and move everything else on the other side. So that 25y to the fourth will remain on the left side, 25y to the fourth dy dx. But for that 12x dy dx, I'm going to move that over to the other side, and it becomes a minus 12x dy dx. Then that's equal to 12y will be on the right side. That 35x to the fourth, I can move that over, and it will become negative 35x to the fourth. All right. The left side, I will factor out the dy dx. So dy dx is factored out. What's left will be 25y to the fourth minus 12x. And that's equal to 12y minus 35x to the fourth. Now I need to get dy dx by itself. So that means I need to divide both sides by 25y to the fourth minus 12x. So dy dx would be equal to, it just be 12y minus 35x to the fourth divided by 25y to the fourth minus 12x. Are there any questions about problem number 6? Okay, everyone. All right, number 7. There are two parts here, parts A and B. For the equation y squared is equal to 9x and the point 2515, perform the following. And we got the point 2515. In part A, they want you to do the implicit differentiation to find the derivative of dy dx. All right, in this case, I'll write the equation y squared is equal to 9x. So we know we take the derivative of each side with respect to x, so the derivative of y squared is
2y dy dx.
2y dy dx. Then that's equal to the derivative of 9x is 9. All right, and then next we'll get dy dx by itself by dividing both sides by 2y. So here dy dx is equal to just 9 over 2y. So that's part A right there. Just using implicit differentiation. Now part B is find the slope of the curve at the given point. So at the point 25, 15, that dy dx, that's going to be the slope of your tangent line of that curve. So all we do there is just substitute. Well, the only thing we can substitute out of that ordered pair would have to be the y, because that 25 represents x, 15 represents y. So we just replace the y with 15. So it would be 9 over 2 times 15. 2 times 15 is 30. And we can reduce 9 over 30 to what? 3/10. Divide the numerator and the denominator by 3. So the slope of that tangent line to that curve would be 3/10. All right, questions on number 7. Okay, and finally, number 8 is finding the derivative of each logarithmic function. Okay, so let's say we have the derivative with respect to x of the natural log of 3x squared plus 4. And I want to find its derivative. Like from here, what would be the derivative of the natural log of 3x squared plus 4?
6x.
Let's start with this, the derivative of a natural log. 1 over,
Okay.
yeah,
3x squared plus 4.
okay. And then we take the derivative of the 3x squared plus 4, which is 6x. And I think I know where you were going with that. Because here that 6x will be 6x over 1. 1 times 6x, that would be 6x in the numerator. The denominator will end up being 3x squared plus 4. And that would be your derivative of the natural log of 3x squared plus 4. Okay. All right, are there any questions about part A? All right, and part B, the derivative with respect to x of the natural log of the quotient of 5x plus 2 divided by 5x minus 2. Okay, so now let's apply the derivative of the natural log of whatever. Let's start with that. So the derivative of this part will be, let's start with 1 over this right here, the 5x plus 2 divided by 5x minus 2. Then we're going to multiply by the derivative of that inside function. So what rule do I need to use there to take its derivative? quotient rule. Okay, and the quotient rule is going to be this. The low, that's the 5x minus 2, times the derivative of the high. What's the derivative of 5x plus 2? Just 5. Minus the high, that's the 5x plus 2, times the derivative of the low. Derivative of this low would be what? 5. And all that's divided by the square of that low, which is 5x minus 2. Now, this 1 over the 5x plus 2 over 5x minus 2, if I flip that over, it will become what? What's the reciprocal of this?
5x plus 2. You said the reciprocal.
Yeah, because this means you can flip this over and you'll get what? 5x. The minus 5x minus 2 will be on top.
Okay.
And then 5x plus 2 will be in the denominator. Okay? Because 1 over this means the reciprocal of what's in your denominator. Because I would take that part and just flip it over. And then this is going to be multiplied by, let's see, if I distribute the 5 over the 5x minus 2, I would get,
25x minus 10.
now, if I distribute the minus 5 over 5x plus 2, that's going to be minus 5 times 5x, which is,
Minus 25x.
okay, and then you have minus 5 times that plus 2, negative 10. All that's divided by 5x minus 2, quantity squared. And I'll go ahead and do this. This 5x minus 2, and I got one of those 5x minus 2 in the denominator. One of these will divide out with this 5x minus 2. And I'll be left with a 5x minus 2 in the denominator. 25x minus 25x, that is gone. Okay, so minus 10 and a minus 10, that's going to be negative 20. Over, and I got 5x plus 2 in the denominator, and 5x minus 2 in the denominator. So this will end up being the derivative of the natural log of the quantity 5x plus 2 divided by 5x minus 2. Any questions about part B of problem 8? Or does anybody have any questions about what will be on your third exam on Wednesday? Okay.